Right, I'm going to complete the impossible. I'm going to get a recurring decimal, which is 0.333333, or 0.3 dot. Or I think in maybe America, I'm not sure, they write it as 0.3 bar. I don't know, they do weird things there. Obviously that 333 recurring is going to be a third. But I'm going to do the impossible. I'm going to get numbers and just pluck them out of nowhere and try and show you how to represent them as a recurring decimal. You know, things like 0.18, 18, which is going to be 0.18 dot dot, and just for the American bros, 0.18 bar. I don't know what them lot are doing. That's going to be 2/11. How am I doing this voodoo magic? How is this possible? So let's do it. Okay, let's start with 0. Okay, let's just 77777, yeah? So, or 0.7 dot, or for the Americans, why are we doing this? There's a line over the top, yeah? How are we getting this into a fraction? How do we do this? So we're going to make x equal 0.77777 dot 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 dot, and so on, yeah? Let's call this our equation 1. It's not an equation, it's just whatever. We'll call it equation 1. And now let's multiply the left-hand side and the right-hand side by 10. So you're going to get 10x equals, what's this times 10? 7.77777, and so on. That's an equals, that's an equals. And we're going to call this number 2. So now take 2 and subtract it from 1. So what you do is everything on the left-hand side, you subtract from everything on the left-hand side here, right-hand side from the right-hand side. So it's going to be 10x minus x is equal 7.7777 minus 0.77777777777, whatever, yeah? So obviously what you've done there is forgetting the left-hand side, we don't really care about that, but the right-hand side is you've eliminated the recurring part. So 7.7 recurring minus 0.7 recurring is just going to be 7, and then that is going to be 9x. Now let's solve. So x is going to equal 7/9. That always feels like as if you've hacked maths. That's how I describe it. But anyway, let's make it a little bit more complicated. All right, you got 0.521. Or, oh God, why am I catering for the Americans? We're not going to do that. Anyway, so what does that mean? That means it's recurring 0.521521521521521521 and so on. So this is a bit different to what we had before. So you do the same thing again. We'll do x equals 0.52152151, and this is equation 1. But now what we want to do, if you saw what the trick was, is we're trying to bunch all the recurring numbers so that when we subtract them, they all disappear, they all vanish. And that is the trick for this, is by going, what do I need to times this by for it to basically have 521 all on the left-hand side and then a recurring 521? It'd be 1,000. So let me times this left-hand side by 1,000. I'd get 1,000x. And the right-hand side would be 521.521.521.521. And sorry, I should put some dots here. They are recurring forever. So when I subtract them now, you're going to now get 999x, obviously 1,000x minus x is 900. Then 521 point all this recurring minus this is just going to be 521. Now if we solve it, x would equal 521 over 999. So pretty simple, pretty good, we're pretty good. But let's make it a little bit more complicated. What if we have 0.52111111? So you've got two, standing digits and then one recurring number. This is going to look like, or 0.521 dot, yeah? So we have x equals 0.5211111, which is 1. If we have 100x, would equal 52.111111. That's number 2. And then what about 1,000x? 1,000x is going to be 521.1111, which is 3. But what we've now been able to cheekily do here is, look, all the recurring numbers are grouped in these two. So if we did 3 minus 2. Forget number 1. 3 minus 2. You're going to get left-hand side 1000x minus 100x, which is going to be 900x. And here on the left-hand side, the recurrings are going to cancel out, and you're going to get 521 minus 52, which is going to be 469. So then x is going to be 469 over 900. Hopefully this has helped nobody. Can you believe I voluntarily do this?